Hello everybody and welcome to lesson 6.6 on solving radical equations. Today's goals are going to be to solve radical equations in one variable and identify extraneous solutions. As well, we also want to be able to solve radical equations by graphing systems of equations. Today's vocabulary only includes really one new term, which is a radical equation. It just means an equation that includes a radical sign. So whether that's a square root or a cube root, fourth root, a half a root, whatever the index of your radical is, doesn't matter, but just having that little radical sign, the thing that we're talking about, these kind of roots of equations of different powers. Okay, so solving radical equations algebraically, pretty straightforward. You're going to see that you're not going to have too much trouble doing this kind of stuff. A radical equation has a variable in a radicand. When solving a radical equation, the result may be an extraneous solution. So the radicand is just this whole thing, that little radical symbol. So it says has a variable in a radicand. So we're specifically saying a radical equation is not like x plus the square root of 2. We need to be taking the square root of a variable to call this a square root equation or a radical equation. We want the variable to be under the square root. If we just had a constant square root off to the side, so if we imagine like y equals 2x plus the square root of 5, well, that would be a linear equation, right? That would just be a linear equation. That would not be a radical equation. So radical equations have the variable as a part of the radicand. Okay, so we want to, first step, isolate the radical on one side of the equation. So isolating it on one side. So for this example, you'd get that 2 away from the left side and isolate the radical on the left side of the equation. To eliminate the radical, you need to raise each side of the equation to a power equal to the index of the radical. So the index is like the number, trying to find some examples, would be the number that we would typically write in this little position. So let's see if I can do some labeling here. So the index goes right there. Okay, got my vocabulary right. Radicand should have a D there. Okay, so you've got your radicand and you've got your index. So if we wanted the square root of 100, it could look like that. If you wanted the cubed root of 27, it could look like that. Okay, so they said the way that we get rid of these things is we just raise it to a power that matches the index. Okay, so if I'm taking the square root of a number, but then I square that, well, I've done two opposite operations, right? I've made it smaller and then I made it bigger. This one, if I take the cubic root of 27 and then I cube that result, well, I've just gone in two different directions. Imagine a physical cube. Imagine, I don't know if I have cubes around here. Pretend this is a cube. We'll cut it off like here in the image. Okay, so you've got a cube. So the cube root, if this cube is 27 cubic units, well, then it must be 3 by 3, so 9 times 3 again. 3 by 3 by 3, 3 in 3 different dimensions. So if I take the cube root of this cube, I get the side length. If I take that side length and I cube it, so I take a length and I cube it, it just means make a cube with a side length that we start with. Okay, so those are kind of our general ideas there, and we will move on with example 1 in the next video.